Okay, so let's start now to talk about how to sample well. So in a convenience sample, the researcher chooses easy to reach members of the population. In voluntary response sampling, people would decide whether they want to even join a sample. Both sampling methods suffer from bias due to personal choice. The best way to avoid this problem is to let chance choose the sample. So that's going to be the idea of random sampling. Okay. So random sampling involves using a chance process to determine which members of a population are included in the sample. So the easiest way to choose a random sample of n people is to actually write their names on it's the hat method. Write their names on a piece of paper, put them in a hat, mix them up well, choose them until you have the number that you want. Okay, an alternative way of this would be a similar idea, but instead of writing their names on a piece of paper, you can assign everybody a number and write the numbers on a piece of paper, put them in the hat, mix them around, and choose them until you have enough of what you want. Okay, so that would work just as well. You can also use that to do for a population that would consist of maybe even animals or things. So the resulting sample would then be called a simple random sample. Okay. Consists of n individuals from the population chosen in such a way that every set of n individuals does have an equal chance to be the same actually selected. So as a simple random sample gives every possible sample of the desired size an equal chance to be chosen. It also is going to give each member of the population an equal chance to be included in the sample. So picture drawing 20 slips, which would be the sample, from a hat containing 200 identical slips. Any 20 slips have the same chance as any other 20 to be chosen. Also, each slip has a 1 in 10 chance of being selected. So some other random sampling methods give each member of the population, but not each sample, an equal chance. So we're going to look at some of these in a little bit. The hat method won't always work well. So obviously, if your population is 1,000, you're not going to want to write down 1 to 1,000 on a piece of paper, find a hat big enough to put them in, and then choose from them. In practice, people using random number generators by technology to choose their samples. If you don't have access to technology, you can also use a table of random digits. So the technology piece we're going to talk about in class, very easy. I'm going to quickly show you how to use a random digit table that is also part of your reference guide for the test. Okay, so a table of random digits is a long string of digits, 0 to 1, with these properties. Each entry in the table is equally likely to be any of the 10 digits. The entries are independent of each other. That is, knowledge of one part of the table gives no information about any other part. So how you're going to use an SRS, how you're going to choose an SRS from this table. They call it Table D, and that's what it's labeled in your reference guides. So the first thing you're going to do is label. So you'd have 16 names. You're going to label them 1 through 16. Okay. The numerical value does have to be of the same length. So if it's 1 through 16, the highest is a double digit, so you're not going to label 1, 2, 3. You're going to label it 01 or 01, 02, 03. And then you're going to go to the table. So you're going to read consecutive groups of digits of appropriate length from Table D. Your sample contains the individuals whose labels. So let's just look at a question so you kind of understand how to use this. And it's easy, but it's not It's also not usually what you would use. You'd use technology, but we'll talk about that in school. So the school newspaper, so this is an example. So the school newspaper is planning an article on family-friendly places to stay over spring break at a nearby beach town. The editors intend to call 4 randomly chosen hotels to ask about their amenities for families with children. They have alphabetized a list of all 28 hotels in the town. So we're going to use Table D at a certain line, 130, to choose our SRS of 4 hotels for the editors to call. Okay, so here's that long list of 28. Okay, in green, that box, all those numbers, that's line 130 in your Table D. Okay. So then the first thing I'm going to do is kind of separate them, right? So as I go through the list, I'm going through every second number, right? So 69. 69 is too high, so that's no good, okay? Your highest number is 28, so 69 is not possible. Then you get to 05. There's your first one. Then you get to 16. There's your second one. 48 is too high. There's 17. There's your third one. 87 is too high. 17 repeats. 40 too high, 95 is too high, 17 repeats, 84, 53, 40, 65, or 64 rather, 89, 87 are all also over your total, which brings us to your last one, 20. Okay, so your simple random sample of 4 hotels would be the Beach Castle, Radisson, Ramada, and Sea Club using line 130 in Table D. Okay, so let's talk about a few other kinds of sampling methods. Okay, so the basic idea of sampling is pretty straightforward. Take an SRS of the population and use your sample results to gain information about the population. Unfortunately, it's difficult to get an SRS from a population sometimes. So imagine trying to get an SRS of all batteries that are produced in one factory in one day. Or let's say find something out about all U.S. high school students. You may not be able to even get an accurate list of all these things. And it would be far too time consuming to collect data from each individual that is randomly selected. Okay, so sometimes there are statistical advantages to using more complex sampling methods. One common alternative to an SRS involves sampling important groups called strata within the population separately. These subsamples are combined to form one stratified random sample. So to select a stratified random sample, you're going to first classify the population into groups of similar individuals. You're going to call those groups strata. Then you're going to choose a separate SRS in each stratum and combine these SRSs to form your full sample, okay? So something like that would be if you're talking about the U.S. high school students, right? So if you separated them by class, freshmen, sophomore, juniors, seniors, okay? So you were separating them, putting them into groups of similar individuals. Then after you have them separated like that, you can then take an SRS within each of those groups, put those samples together to form one big sample. Okay, so stratified random sampling works best when the individuals within each stratum are similar with respect to, is similar with respect to what is being measured and when there are large differences between each strata. So if there are large differences between each strata, you're likely to find more than you're even looking for in something. You could probably have a further idea of why results are the way they are because you kind of have separated them into groups, so you could kind of draw further conclusions about them. something we're going to do in class. Okay, although a stratified random sample can sometimes give more precise information about a population than an SRS, both sampling methods are hard to use when the populations are way too large or spread out over a wide area. In that situation, we'd prefer a method that selects a group of individuals that are near one another. Okay, so this would be called a cluster sample. So to take a cluster sample, first divide the population into smaller groups. Ideally, the clusters should mirror the characteristics of a population. It's just on a much smaller scale. So then you're going to choose an SRS from those clusters. So all the individuals in the chosen clusters are included in the sample. So I'm just going to go back to that high school idea. So imagine that a large high school, right? Say that they have homerooms that are assigned alphabetically, okay? So in other words, it's not realistic, but let's say they have homerooms that, or advisories in your case, right? Advisories that are made alphabetically. Well, then theoretically, you're going to have all different classmen in each advisory, okay? So let's say we needed to survey 200 students randomly, okay? Could be a little bit difficult to survey 200 students, okay? But it could be beneficial if you took a cluster sample. So if I took a cluster of 8 homerooms, if they had 25 students each in them, okay, that would be my 200 students. So I get a simple random sample of the 8 homerooms, and then within those 8 homerooms, we'll take, I already took a random sample. So the clusters now are not alike within. So you have freshmen, sophomore, junior, seniors in all of your clusters, okay? What you did was took a simple random sample of the different clusters out there. So stratum contains similar individuals and large differences between, so they're the same among but different throughout, where clusters look like the population but on much smaller level. So they're different among, but they're the same throughout. So what I mean by that is stratum are the same among, so within each strata, they're the same. All freshmen, all sophomores, all juniors, but they're different throughout, so each strata are different. With the clusters, they're different among, so in each cluster, they are very different individuals. You have clusters with freshmen, sophomore, junior, seniors, okay? But they're the same throughout. So all of the clusters have different classmen within them. Okay. So this just is kind of piggybacking the whole idea with high school students, okay? So describe how you would use the following sampling method. So let me see if I can give you background on this. Okay, so the student council wants to conduct a survey during the first 5 minutes of an all-school assembly in the auditorium about using the school library. They would like to announce the results of the survey at the end of the assembly. The students council president asks your statistics class to help carry out the survey. So here are the 800 students present at the assembly. A map of the auditorium is shown on the page. Note that students are seated by grade level and that seats are numbered 1 to 100, okay? Or 1 to 800 rather. So you have to kind of use this key down here to understand kind of 1 through 200 are your seniors, and then so on. Oh, I don't have the answers. We could just talk about them. So how would I take a simple random sample? So to take a simple random sample, you're going to need to choose 80 of the seat numbers at random. So you can use your your table D, or you can use your technology to generate 80 different numbers. Then you're going to give the survey to those students that sit in those numbered seats that were chosen. Okay, a stratified random sample would look a bit differently. So because students in the assembly are seated by grade level, because students' library use might be similar within grade levels, but different across grade levels, we'll use the grade level seating areas as our strata. So within each grade seatings, we'll select 20 at random. So we'll use strata, so of 1 to 200, so that be one group, 201 to 400 be the other group, and within those 4 strata, those 4 groups that are the same within, we'll choose 20 simple random samples within those 4 groups. And then finally, your cluster sample. With the way that the students are seated, each column will have a mix of 9th through 12th graders. So you could kind of take a cluster that contains students from all four grade levels if you kind of talk about each column. So because there's 20 clusters, because there's 20 columns here, because there's 20 clusters, each with 40 seats, you would need to choose 2 clusters at random to get 80 students for the survey. Okay, you would choose them randomly by technology or using table D. Okay, let's call that it for this video.